Probability is another pillar that supports the statistic and the probability tempo. It is the tool we use to measure and quantify the randomness. There are three common definitions of probability. These are axiomatic definition, the relative frequency definition, and the classical definition. Now, please allow me to explain them one by one. Just kidding, don't close the video. 1. Learning a mathematical concept. The alien's feeling of the math language can easily be overwhelming. Also, a lot of concepts are not particularly interesting, and you probably have no idea where and when you will use it. So, as you know, the lack of motivation means the most of them are quickly forgotten. Math exists to address real-world problems. It doesn't have to be that hard and abstract. Here, let me try to explain it in plain language. Probability is the branch of mathematics concerning numerical definition of how likely a random event is to occur, or how likely it is that a proposition is true. There are two keywords in this definition: random event and numerical description. To understand random event, let's explore several examples. Flipping a coin. It shows head next time is a random event. Team A win the next game is a random event. Elon Musk recently shared about his plan to send 1 million people to Mars by 2050. Here, send 1 million people to Mars by 2050 is a random event. Sum up. First, define the condition. Next time. Next game. By 2050. Then, that could happen. Show head. Team A win. And send 1 million people to Mars. And it has to be random, such as there's 50% you will see the head. Team A has a 60% chance to win the next game. And the chance of sending 1 million people to Mars by 2050 is, well, we will see. By the way, the random event could refer to a future event, like win the next game, or the event already happened, we simply don't know yet, like the chance you find your dog's pee on the carpet when you're back home. For me, the chance is 50%. Numerical description. Say you know a team has a great chance to win the next game, but can you be more specific? Actually, you can. Like in our example, 60% to win the next game. I know, right now you're probably wondering how to get that number in the real world. Well, Bayes' theorem can be used to address this problem. We will talk about it in another video. Knowing that probability is a numerical description of a random event, our next question is where this numerical description comes from. It is the ratio of the outcome in the event to all possible outcomes in the event. In statistics, we normally call the set of all possible outcomes or result of the event sample space. For example, flipping a coin, the sample space going to be head and tail. Toss a single 6-sided dice. The typical sample space is 1, 2, 3, 4, 5, and 6. It is obvious that every event has a value between 0 and 1, since it's only a subset of the sample space. The probability of something is 0 means it won't happen at all. Probability is 1 means it must happen. The sum of all probability for all possible value must equal 1. The probability of opposite or complement of an event is 1 minus the probability of that event. For example, this team has a 60% chance to win the next game, equal to there is a 40% chance won't win next game. However, in the real world, in most cases, find a complete sample space is impossible, which makes our prediction not that precise. However, we will never stop to explore our world, always work on improve the prediction of various events around us. So, I would like to say, don't be intimidated by the pursuit of the infinity of truth. You will find joy in each step. I'm always here at your service. See you in the next one.